Okay guys, let's take a look at our change of base formula, starting by just stating simply what it is and what it allows us to do. So let's go ahead and start with the fact that, talk about change of base formula. We have something of the form log base a of x. Let's see if I can write this a little bit better for you guys here. Log base a of x. The change of base formula actually allows us to change this to any base that we like, as long as we write it as a ratio of two logs here, and the log bases have to be the same. But the fact is, if we were to take the x here, which is the thing that we were taking the log of initially, and put it up on the numerator log, and if we were to take the a, which was our base on our log initially, and make it the argument of our log in the denominator here, then what we would be allowed to do is change this green letter b to whatever we would like. And so the simple fact of the matter is, I could evaluate all of these logs down here. We have log base 3, log base pi, and log base 4. If my calculator had a log base 3 or a log base pi or a log base 4 button, but it doesn't. As a matter of fact, the only two log buttons that we tend to get on our calculators are our natural logs and our common logs. And so what we're going to do is we're actually going to bypass this little formula right here, and we're going to say that really if I have log base a of x, then I can really rewrite this as the natural log of x over the natural log of a. And the reason why this works is because we have two logs here that have the same basis, base e. The same reason why we could also use a common log on both of these, log base 10 over log base 10. As long as we put the x on top and the a on bottom, then this would be an equivalent expression. So in terms of what this allows us to do, what does the change of base formula allow us to do? We could just say that the change of base formula allows us to rewrite any log as having a different base than what it started with. And our goal is to rewrite in terms of ln, or log base 10. So we're going to rewrite this most of the time in terms of our common log or our natural log, so we can go put this into a calculator. So my instructions on this are pretty simple. It says rewrite the expressions using the change of base formula. Then let's go use a calculator to evaluate the following expressions. And then I want to round our answers, since they're exponents here, to 3 places. And so what I've got here is 3 to the what power equals 7. Well, according to the change of base formula, I'm going to use natural logs here, but I could rewrite this as the ln of 7 over the ln of 3. Now, in terms of where the 7 and 3 go, remember that the 7 is the thing we were taking the log of in the first place, and that number is always the number that we represent up on the top log. And then the subscript here, always, or the base on the natural, or the original log, goes on the bottom. So ln 7 over ln 3, what I just want to do is I just grab my calculator here, and we're going to type in ln 7. Let me turn this on. So we have ln of 7. Notice that I have to put an end parenthesis on this before I type in my next ln, but we'll say ln of 7 divided by the ln of 3. So say ln of 3. I get this decimal here, and out to 3 decimal places, this would be about 1.771. So I'm going to say this is approximately 1.771, and I'm going to write that up here as well, 1.771. Now, a couple things that I want to check. First one is this. If I had used common logs, log 7 over log 3, would I have gotten the same thing, 1.771? So let's go check this out using our common log, log 7 end parenthesis over log 3 end parenthesis. And you should see that this still gives you the same value here, because the change of base formula allows you to account for that as long as your two logs have the same bases and this ratio that you rewrite it as. So that being said, the other thing I want to check is this. Do we indeed get 3 to the 1.771 power come out to be 7? So rewriting this exponentially, this would say 3 to the 1.771 is approximately 7 here. And what I want to do is check this out. So if I said 3 to the power of 1.771, then what I get is approximately 7. Now, why don't I get exactly 7? Well, the reason why is because I had only used an approximate value for the log base 3 of 7. If I would have used perfectly the log base 3 of 7, the funniest thing happens. As a matter of fact, we use our inverse property of logs that says, excuse me, an exponential thing raised to a power of a logarithmic thing, as long as they have the same bases, they cancel out and we get left with that 7 right there. So we would say that this indeed does work. I just want to check on these values here. So let's find log base pi of 9.8596 here. First things first, let's rewrite it. I'm partial to natural log, so 9.8596, the natural log of that over the natural log of pi. And as we do this here, we would say, okay, well, get our calculators out here. we've got the natural log, let me clear this out, natural log of 9.8596 divided by the natural log of pi. Now pi is right behind your to the power of key here, natural log of pi. And so we would get this right here, we get 1.999. So approximately 1.999 here is our logarithm value. And then for this last one here, when I say rewrite this using change of base, you'll notice that we have 100 minus 3 times this log that I want to rewrite here. And so the way we're going to have to do this is 100 minus 3 times. Now in parentheses, here's where we'll put our change of base formula. Excuse me. So we have the natural log of 4, natural log of, not 4, natural log of 18 on top over the natural log of 4. So using our order of operations, we'll definitely want to start inside here first. Now the interesting thing is, when I do this, ln 18 over ln 4, ln 18 divided by ln 4 is going to be this long decimal that never stops. And so when I round this, 2.085-ish, 2.085-ish, what I want you to know is that we're going to take 100 minus 3 times this, but we're not going to use this approximation. You're going to keep this up on your calculator. And so what I'm actually going to do is type in 100 minus 3 times, and the neat thing is behind your negative key it says ANS. You can just type in my last answer. And so by doing this, we actually get 100 minus 3 times this entirely infinitely long decimal. And we get approximately, let's write this down here, approximately 93.745. So 93.745 using our change of base formula would be the approximate value here. Cheers.